Screen is visible?
Yes, sir.
Okay. Serial number 20. Okay. So in the previous class, we have discussed about this Maxwell inductance bridge. Okay. So Maxwell bridges we are going to discuss today. Can anyone tell how many types of Maxwell bridges are there? Any one of you? How many types of Maxwell bridges are there?
2 types.
2 types. Can tell the anyone name of those 2 types? One is already displayed here. Okay, Maxwell inductance bridge, it is already displayed the name here now. Another one. Another bridge name. Yes. So the Maxwell bridge actually we are going to use for the measurement of self. Just a minute. Due to internet connection, it was disconnected. Once again, I will share. So is it visible now? Screen is visible or not?
Yes, sir.
Okay. So Maxwell bridge we are going to use for the measurement of self-inductance only. We are going to use for the measurement of self-inductance. But the bridges are this bridge. It is an advanced form of the it is an advanced form of the Whitson bridge. Okay, but it has 2 types. One is the Maxwell inductance bridge. Based on this, Maxwell has derived this bridge for the measurement of self-inductance. So the Maxwell inductance bridge name came here. But if we are using combination of inductor resistance, inductance, capacitance, then on that condition, the name second name came Maxwell inductance capacitance bridge. The capacitance act as just a known value. We are not going to measure the capacitance value out. We are used these bridges for the measurement of the inductance only, self-inductance only. We are going to use here. I told it is an advanced form of the Maxwell-Whitson bridge. Instead of resistances, we are going to use impedances here in the AC bridges. The DC bridges, we are going to use the resistances, but in the AC bridges, the resistances are replaced by the impedances here now. So according to the Whitson bridge, what is the formula? Balanced condition. Under balanced condition, what is the formula? Leave that one. See this one. Okay, this one we are going to call this one as Z1 here now. So this one we are going to call as Z1 here now. So this one it is called Z2. It is called Z2. And this thing it is called Z3. It is called Z3. And here this one we'll call it as Z4 here now. It is called as Z4. Can anyone tell me what is the formula for Z1? How we can write Z1 equal to? This is the Z1. Z1 equal to what? The resistance is there. That is the real part. In the complex form, we have to write Z1 equal to R1 plus what is this one? L1 is there. L1, what is the reactance of this L1? XL1 is, yes, XL1, that is called, but it is a imaginary part. We are going to use R plus JXL1. This one. Is it correct? Z1 equal to R1 plus JXL1. We can write like this. The Z1 equal to? Yes?
Yes, sir.
So similarly, I told that one Z1 equal to R1 plus JXL1. Can anyone tell me what is the formula? How we can write Z2? Z2? Anyone can tell me? Z2 equal to what? Yes.
R2 plus JXL2.
R2 plus JXL2. Very good. Is it over? JXL2. What is this one? It has some resistance, no? Yes or no?
Yes, sir.
The resistance is real term or complex form? Plus R2 we have to write here. This R2 and this R2 are connected in series, and L2 is also connected in series. So for the reactance we have used imaginary term. For the resistances, that is real term only. Next, Z3 equal to Z3 equal to and Z4 equal to. Any one of you tell me. Z3 and Z4. फास्ट फास्ट बोलना चाहिए आप लोग, इंटरेक्ट हो जाओ. रोल नंबर 1 बहुत कम क्लास अटेंड करते हैं आप. रोल नंबर 1. रोल नंबर 20 Vinayak. Gore Vinayak.
Yes, sir.
What do you mean by Z3? What is the formula for Z3? Here it is their equation. According to this circuit, Z3 equal to what? Is there any imaginary term here?
Yes, sir.
What is that one then? See, if A plus JB we are going to consider means A is a real term and B is a imaginary term we are going to call in the complex form here now. So if J indicates it is complex term here now, it is the real term here now. It is like a resistance, it is like a inductance here now. Is there any imaginary term here? There is no imaginary term, only real term is there. We can tell Z3 equal to R3 directly. Z3 equal to R3 we can write, or Z3 equal to R3 plus J0. 0 we can use here now. The imaginary term here now is there. There is no reactance at all over there. And Z4 equal to
R4 plus J0.
R4 plus J0 or only R4. You can write only R3 and R4 on here. This term we can remove. Just for understanding, I am telling that one. So we have identified Z1, Z2, Z3, Z4. Now what we have to do? According to the Wheatson bridge, we know the formula. Under balanced condition, the bridge R1, R4 equal to R1, R4 equal to
R2, R3.
R2, R3. Very good. R2, R3 here now. In the place of R1, you substitute Z1 here now. Z1, Z4 equal to Z2, Z3. Can write like this. Z1, Z4 equal to Z2, Z3 here now. Here Z1 is there. You substitute this Z1 value here, Z2 value here, and equal, sorry, Z4 value here equal to Z2 is here, Z3 is here now. Then we'll get the another equations. I will show the next slide. I have already written here now. See here. First I'll tell that L1 is nothing but that is inductance, unknown inductance of that resistance R1 here now. This part is unknown. Yesterday only I have told already this one. Okay, L2 is variable inductance of fixed resistance R2. R2 is variable resistance connected in series with inductor L2, and R3 and R4 are the known non-inductive resistances I have already told here. So the value of R3 and R4 resistance varies from 10 ohms to the 1000 ohm with the help of rheostat box here now. Here we have used, not used. We can change. You can use any box over there here. Variable or known values, that one. At balanced condition, considering the Wheatson bridge, Z1, Z4 equal to Z2, Z3 here. This one also how we got, I can tell like that also. But directly at Wheatson bridge, we know that one. So Z1, Z4 equal to Z2, Z3 here. According to this circuit, we have written Z1 value equal to R1 plus JXL1. XL1 is nothing but what you can write? XL1 equal to, yesterday I told. Yes.
Inductive reactor.
Omega L1. XL1 equal to omega L1. Omega equal to 2 phi f again here. So directly we will use omega L1 we are going to use here. Z1 equal to R1 plus JXL1. In the place of XL1, I have used omega L1 here. Now this term. Next Z2 equal to, here two resistances are there, R2 plus R2 plus JXL2, that is called J omega L2 we have used. There is no imaginary part, only real part is there. R3 equal to Z3 directly. Z3 equal to R3 plus J0, that is nothing but R3 only. Z4 equal to R4 plus J0, that is nothing but R4 here. Now what you do, to substitute Z1 value here, Z2 value here, Z3 value here, and Z4 value to substitute here now. Substituting that one, I will substitute, just a minute. Rule number 18. Okay, I'll substitute Z1 value. Z1 value kya hai? R1 plus J omega L1 I will write here. Next Z4 is what? Z4 equal to R4. I have written R4 equal to sign I have written here. Next Z2 equal to R2 plus R2 J omega L2. R2 plus R2 J omega L2. Z3 equal to R3 I have substituted here. I have substituted. Next what we have to do? We have to split the term here now. R1 into R4, we can write R1 into R4 here now. Plus symbol is there, I will use plus symbol. J omega L1 into R4, J omega L1 into R4 here. This R4 first you multiply here and plus symbol you multiply here now. So I am splitting the equation now. Equal to, see here 1, 2, 3 terms are there here now. We have to multiply with R3 here now. R2, R3, we can use R2, R3 or R2 plus R3 directly they have used. Directly also you can use this one here. R2 plus R2 into R3. This is the real part one term we have made and this is the imaginary part one term. J omega L2 into R3. This is one term. So number 4. Okay. Now what we have to do? We got the equations here now. We have got one equations here now. So this is the last final equation we got here now. From this equation, what we have to do? We have to separate real part and imaginary part. If the J is there in that complete term, that is called imaginary term. If J is not there, that is called real term. So can anyone tell me? First we will do the real term part separately. What are the real part here now? R1, R4 is the real part.
Yes, sir.
So R1, R4 is the one real part here. Next, J omega L1, R4 is real part. No. Next, R2 plus R2 into R3.
Real.
Real part. I will consider this one around back here. Next, J omega L2, R2, R3.
Imaginary.
So what I will do, I will write only this time here real term, here imaginary part I will write here. Now real part is R1, R4, R1, R4 I have written. Next it is a imaginary part, equal to is there, equal to I have to write. Next this one R2 plus R2 into R3 I have written here. So according to this circuit, this is the unknown part I told that one. The R1 is the unknown resistance. Yes or no? R1 is the unknown resistance here now. So R1 equal to R2 plus R2 into R3 divided by R4. We got the equation. Yes or no?
Yes, sir.
So comparing with the Wilson bridge, you compare over there. The second branch resistance was R2. Okay. This R2 plus R2 is nothing but total R2 only, na? It is total R2 only, na? R2T. I will write that one. R2T. So again we got the equation R1 equal to R2 R3 divided by R4 only. Same we got like a Wilson bridge only. Yes or no?
Yes, sir.
If two resistance, instead of using two resistance, if he has used only one R2, then it is same like a Whitson bridge here. So this term is over now. Next, imaginary term you go here. So J omega L1 R4, J omega L1 R4 equal to J omega L2 R2 here, L2 R3 here. Which term will get cancelled here, you tell me. Here also J is there, here also J is there. Can I cancel J? Both will get cancelled.
Yes, sir.
J will cancel here now, here also. Omega, here also omega is there, here also omega is there. Again, omega will cancel here now. L1, there is no L1 term. R4, there is no R4 term. So what we can write? We can write the formula L1 R4 equal to L2 R3. L2 R3 we can get here now. Which is the unknown inductance here? What is the unknown inductance here now? Two inductances are L1 and L2. In this one, which one is the unknown? Which one is the unknown inductance? L1 is the unknown inductance here now. So L1 equal to what you have to do? L2 R3 we keep as it is here now. L2 R3. You send this one into RHS side. It will become L1 equal to R3 R2 L2 divided by R4 here now. This is the final self-inductance formula. To measure the self-inductance formula, we are going to use these two equations here. All of you note down these two equations. These two equations are the Maxwell inductance, unknown resistance or inductance formulas are there. I will ask one question here now. The equation number 1, you consider this one, equation number 1, and this one you consider as equation number 2. Is these equation number 1 and 2 both are dependent to each other or independent from each other? Just tell me that one. Equation 1 is dependent on equation 2, or equation 1 and 2 both are independent to each other? You tell me that answer. Yes, anyone? सोचो थोड़ा, सोच के बोलो, दोनों डिपेंडेंट है क्या इंडिपेंडेंट है? Same equation we can write. We know that according to Ohm's law, we know the formula V equal to IR. The bridge will be under balanced condition. What will happen? VAB equal to VAD will be, comes over there. VAB. I will take this circuit diagram here now. Then it will be directly use किया ना हमने अभी. According to Whitson bridge, we will get this direct bridge equation. I told that one. Without referring the Whitson bridge also, we can calculate the bridge equation by considering the equations here. I will show you how. Just for your understanding, I am taking this equation. Okay, see here. Here the diagram is there. This is A and B. Voltage drop across A and B equal to voltage drop across A and D are equal. Then we can say that one, the bridge is under balanced condition here. So that is called VAB equal to VAD. I have written here now this one. So VAB is nothing but this is I1, current flowing through I1. According to Ohm's law, what is the formula? V equal to IR for the DC here now, if only resistance is there. So for the AC bridges, resistance is replaced by Z. Is nothing but V equal to IZ. We can write. Yes or no? V equal to IZ. So VAB is nothing but I1. The current flowing through this one is I1, and the total term is called, that is called Z1 here. Now we can write I1 Z1. That is called VAB. I1 Z1 VAB. Next, VAD, which current is flowing here now? I2 is flowing here now. I2 into Z2 here now. I2 into Z2. So Z1 equal to what we have to write? Z1 equal to R1 plus JXL1. Just a minute. Okay. So here the Z1 equal to R1 plus JXL1, R1 plus JXL1, we have to write down. Say in the place of Z1 you write down this formula, Z2 you write down R2 plus R2, this capital R2 plus small r2 into JXL2 here now. Similarly, what you have to do, this one I1 plus R, this one for VAB equal to VAD, A ho gaya abhi. This term is over now. If one condition for the balance. Another equation for the balanced condition is if the voltage drop across this CB equal to CD, then also the bridge is said to be balanced here. So for that reason, VBC equal to VDC. I will consider VBC equal to VCD here now, or VDC here now. So VBC equal to which current is flowing here now? If the bridge is balanced, then I1 is same current will flow here. So that is called I1 into Z3. Here I2 is flowing here now. I2 into Z4 here now. So I1 equal to I1 Z3 equal to I2 Z4 here now. What is Z3 equal to R3? Here there is no imaginary term. Only Z3 is there, R3 is there. So Z3 equal to R3. Here Z4 equal to R4. So you substitute I1 R3 equal to I2 R4. So this equation consider as equation number 1. This one you consider as equation number 2. Now here also I1 term is there. Here also I1 term is there. Here I2 is there. Here I2 is there. Dividing equation 1 by equation 2 here. Now we will get cancel these terms here. We'll get cancel these two terms here. No. So I1 R1 plus JXL1 equation 1 I will write here LHS side as it is divided by equation 2 LHS side, that is here I1 R3 equal to is there here equal to I2 R2 plus R2 into JXL2 here now LHS of the equation number 1, sorry, RHS of equation number 1, RHS of equation number 2 I have written down here. Here I2 is there, here I2 will get cancelled, here I1 get cancelled here now. What you do, you multiply R3 into here, multiply R4 into here, you will get again the same equation. We are going to get this one only here. So from this again you divide, separate the real term and imaginary term, you will get the same answers. Answer same hai kya nahi, dekho ek bar. Previously whatever we have derived, same answers we got here also. R1 equal to R3 R4 R3 into R2 plus R2 divided by R4. L1 equal to R3 divided by R4 into L2. We got the same equation or not?
Same equation.
Same equations here now. Actual method is this one is the correct answer. We have to do the actual method. In this method only we have to do voltage drop across this, voltage drop across this, voltage drop across this, and this we have to identify under the bridge balance condition how many configuration will come. Based on that we have to identify the equations here now. So R1 equation we got and L1 equations we got. So R1 plus JXL1, that is called Z1. Z1 equal to these two we can use here now. So these two, this is the Z1 is the unknown part here now. So we have identify, we can by using this formula L1 equal to R2 R3 L2 divided by R4, we can calculate the unknown inductance of the circuit here. And I asked one question that if equation 1, this one is dependent on this or independent of this, I asked that. डिपेंडेंट है इंडिपेंडेंट है, कैसे आइडेंटिफाई करते हैं आप लोग? आर यू डिपेंडेंट और इंडिपेंडेंट? यू पीपल्स आर डिपेंडेंट और इंडिपेंडेंट? Who tell me?
Dependent.
Dependent.
Dependent on your parents. Yes. So
Yes.
like that, the equation R1 you consider that one. So here L1 is there. Here this is the head L1. This is the R1 is head here. No. In the equation of R1, is there any L1 term is there here? L1 term है क्या इधर? L1 बोल के है क्या? नहीं है? नहीं है ना? So in the R1 equation there is no L1 term, and in the L1 equation there is no R1 term here. So both the equations are independent to each other. They are not dependent to each other, but independent to each other. So that is the big advantage of this equation here. Now, if R1 के ऊपर depend है तो पहला R1 identify करने का बाद में L1 करना चाहिए. But if we don't know the R1 value, then also we can find the self-inductance value here. No, that is the big advantage of this Maxwell inductance bridge. Any doubts in the equations? Equation लिखने में कुछ doubt है तो अभी पूछो. You can ask. Yes. I'm asking to you people only. If you have any doubts, you can ask me. Don't hesitate. Any doubts to derive this equation? Which difficulty है क्या?
No doubt, sir.
Okay. So according to the equation, by considering the both the equations, the I1 and R1 are the unknown quantities. Sorry, L1 and R1 are the unknown quantities, which are measured in terms of R2, R3, R4, and L2 here now. And R1 and L1 equations, the following points are concluded here. Now you have to remember the following points. The two balance equation is always obtained from the AC bridges here. Both two equations we have obtained. One is for R1, another one for L1 here now. They are always obtained from the AC bridges only. For the DC bridges, only one equation will get that one. Next, the unknown quantities are determined through the balanced equation. The unknown quantities are usually, it may be inductance, capacitance, and resistance. Whatever the unknown quantities we are going to measure, it may be inductance, capacitance, and resistance here. This is common overall for AC bridges. I am telling that one. So the balance equations are independent of frequency. Frequency term is not there. It is getting cancelled here now. So if they are independent of frequency, they are not depending on the frequency also. The AC bridges are also used in the other applications, like in the communication system we are going to use, complex electronic circuit, we are going to use that one here. So this is completes the Maxwell inductance bridge here. Okay, next we will go for Maxwell inductance capacitance bridge here. Maxwell inductance capacitance bridge we are going to discuss here now. Just a minute. Again, I have to take one circuit diagram here. If circuit diagram नहीं है तो आप लोगों को confuse हो जाएगी. I will explain, but explain करने के बाद क्या हो जाएगा? What is that one? Where it is explained? Control C. स्लाइड हो गए क्या? Here, why the name came, that is Maxwell inductance capacitance bridge. Previously, the circuit was consist of only inductance here now. Here inductance was there, was inductance. But the bridge circuit, it has all the combination of resistance, inductance, and capacitance here. We have used one capacitance here now. Capacitance visible hai kya nahi? Is there capacitance here? So one variable capacitance is connected in parallel with the resistance, that is variable resistance. So the variable resistance we have used, variable capacitance we have used, that R1 is the unknown resistance, L1 is the unknown inductance, R2 and R3 are the non-inductive standard or known resistances, we are going to call that one. Known resistances here. Next, again the AC supply we are going to apply. We are going to take the current I1 as a reference. I will take that one. I1, I will take that one. See here. The current will start to flow here. I1 R1. The voltage drop across this one. I1 R1. That is in phase with I1 only. So I will write. I will take here now. So that is called I1 R1. I will mark here. Next, it will go to the I1 L1 here now. J omega L1 we can call that one, which is 90 degree lagging here now. Voltage drop, that is leads here now. Voltage will be leads the current by 90 degree here. That is I1 omega L1 we can call that. Same current it will flow through the R3 here now. So we will write that one as I1 R3 here now. Okay, this end is over now here. Next, I2 R2 here now. Again the I2 R2 will come here only. That is I2 R2. It will where it is now. See here. The I2 and R2 both are lagging. There is a difference, phase angle difference is there. Because I2 R2, see, I1 current is flowing in the inductive load, but the I2 is flowing in capacitive load. Capacitance hai na I2. So here the capacitance is there. So the current flowing through the capacitance, that is I2, leads the current I1 here. Leads the current I1 here. For that reason, we have taken for some angle I2 we have taken here. So I2 R2 here now, which is in phase with I2, that is voltage drop across R2 here now. Next, up to here, the I2 will come. Here two currents will come. One is IR. IR is also is in phase with, that is current, that current only here now, voltage drop that one. Next, IC is very important here. The current flowing through the capacitor, which is leads the voltage by 90 degree, or the I1 we have taken, this current IC is leads the I1 by 90 degree here now. For that reason, we are going to take, this is the IC we have taken here now. From the I1 and I2, I1 and IC, what is the angle here now? This angle kya hai? What is this angle? 90 degree is there here now. Next, again it will flow here now. So the total voltage is between E1, this is E1, and E2 we are going to consider. Here the E1 or here the E2 is there. Both will join together and we'll get the value of that total supply voltage. So this is the phasor diagram creation we are going to tell. Phasor diagram creation we are going to tell. Next, what you have to do? So here, anyone can you tell me what is the formula for Z1 here now? Z1 equal to, again we have to use same formula, Z1 Z4 equal to Z2 Z3. So for that reason, what we have to do? We have to write Z1 equal to
R1 plus J1
plus JXL1. JXL1. Z2 equal to Z2 equal to
R2.
R2. Z2 equal to R2. Next, Z3 equal to
R3
Z3 equal to R3. Very good. Z4 equal to, here the important factor is there. This combination of parallel, it will give the Z4 here. Anyone can you tell me Z4 equal to? Stuck hoga idhar. Okay, I will give one hint for you people. If two resistances, I will tell that one, this is R1 and this is R2 are connected in parallel here. Okay, R1 and R2. These two are connected in parallel here. What is the total resistance? R equal to, what we can write that? Two resistances are connected in parallel means what is the equation? Yes. What is the equation? You people are not a 12th standard students. You have already completed the junior level exam. Means that is nothing but diploma you have completed. It doesn't matter which branch you are, but this is a very basic concept. If two resistances are connected in parallel means what is the formula? Okay, that one also I will leave. If two resistances are connected in series, what is the formula? R1, R2 are connected in series means what is the net value of resistance here now? Total R equal to
R1 plus R2.
R1 plus R2
R1 plus R2 you are going to use. For the parallel circuit, you tell me, na, then.
R1 divided by R2.
R1 divided by
1 upon R1.
1 upon R1. Next.
R1 R2 divided by R1 plus R2.
Someone has told. Come once again.
1 upon R1 plus 1 upon R2.
1 upon R1 plus 1 upon R2 कैसे आ जाएगा मैडम? ये that is not correct answer, I think.
R1 into R2 divided
For
by
parallel.
So it is the correct answer is 1 divided by 1 upon R1 plus 1 upon R2. That is nothing but what you will get. One boy he has told that if two resistances are parallel, the direct equation we are going to consider R1 R2 divided by R1 plus R2. This is the formula we are going to use for the two resistances are in parallel. R1 R2 divided by R1 plus R2. You are not I told that one once again, I will repeat. You are not a 12th standard or persons, you are a engineering persons. You have to remember this is the basic language. All of you electrical and electronics or any circuit branch students, you have to remember this one. If two resistances are connected in series, then the summation will occur. If two resistances are in parallel, then 1 divided by 1 by R1 plus 1 by R2. By doing that one, R1 R2 divided by R1 plus R2 only we are going to get. That one also I will show you how we will get that one. 1 by R1 plus 1 by R2. We are telling like this. Total divided by 1 here. So take the LCM here. No, here R2 is there. Here R1 you multiply here. No. So R1 plus R2 divided by R1 R2. Total LCM is R1 R2. Okay. So this is 1 divided by 1 by 2. Then this R1 R2 it will go up here. Now divided by R1 plus R2. Same equation we have written here. Confused हो गया क्या? ठीक है, I will erase this one. What we can write here, where it went. So here we can write this one, this equation 1 divided by this one here R2. R2 you take the LCM, that is R1 R2 हो गए, इधर already R2 है, so R1 है, R2 multiply करने का, plus इधर R2 है, R1 को multiply करो, R1 plus R2 हो गए, divided by what is the LCM? R1 R2 here. R1 R2. So this term we can send here into this one. Yes.
Yes, sir.
So R1 R2 divided by R1 plus R2. We got the same equation now. Yes. R1.
Yes, sir.
So this is the equation for the two resistances are connected in parallel. That is R1 R2 plus divided by R1 plus R2 here. This is the capacitance we are using. It is nothing but it is reactance only, XC only we are using here now. What is the unit of reactance? That is also ohm only. So then we can tell that one R4 is parallel with XC here now. R4 is in parallel with XC. XC4 that is. So we can write the formula like this. R1 plus R1 XC4 divided by R4 XC4 divided by R4 plus XC4 here. I will tell in the next slide. I will show that one how we have written here now. So these two are in parallel here now. So the unit of reactance is also ohm. The resistance unit is also ohm. So it acts as two resistances are in parallel. So this term we have to write in the reactance term we have to write here. So the Z1 we have written as it is Z1 equal to R1 plus j omega L1. Z2 equal to R2. We have written this is Z2 equal to R2. Z3 equal to that is R3. We have written R3 here now. But Z4 equal to R4 is in parallel with XC4. R4 is in parallel with XC4. but the XC4 is the imaginary term. What we have written? R4 1 divided by j omega C4 into हो गए, into जैसे ही हो गए ना. So this equation, it is like this only. R4 into j, sorry, that is minus j we will get for the capacitance here. That is called XC4. XC4 is nothing but, for the XC is nothing but that is 1 by j omega c. Na? Yesterday I told XL equal to j omega L1. XL equal to omega L. XC equal to
1 by 2.
1 by omega c we have considered here same. R4 XC is 4 is nothing but 1 by j omega C4 we have considered here now. So next plus, sorry, divided by R4 plus XC4, that is called 1 by j omega C4. We have written in the same form now. So next this term here R4 into 1, that is called R4 by j omega C4. Here what we will do, here also I will take LCM here now. Thus R4 into j omega C4 plus 1 will tell that one. Here 1 by 2 divided by 1 by 2, that is this 2 will get cancelled. Yes or no? कैंसिल हो जाएगा क्या नहीं? ध्यान से सोचो थोड़ा. कंफ्यूज है तो बोल दो, अभी क्लियर करता हूं. This one, it is like this here, no? It is like this term. This one we can write, I will write here. You देखो एक बार ध्यान से. R4 divided by j omega C4 है. So divided by term is there, divided by 1 by 2. I will consider that one as into here, no? Numerator to denominator, denominator to numerator. This one I will write in the numerator, that is called j omega C4, j omega C4 divided by 1 plus j omega C4 here. J omega C4 into R4. Now we can cancel this j omega C4 cancel कर सकते?
Yes, sir.
So now the left term is, this is R4. R4 divided by 1 plus j omega C4 R4. So we have written here now R4 divided by 1 plus j omega C4 R4. So this one we have found that Z1, Z2, Z3, Z4 value we have calculated. Next step is substituting this calculated value of Z1, Z4, Z2, Z3 values in the equation number 1 at balanced condition, under the balanced condition. So I will substitute here now. Just check it. Z1 equal to what? R1 plus j omega L1. I will substitute R1 plus j omega L1. Next, Z4 equal to this one, R4 divided by 1 plus j omega C4. I will substitute R4 1 plus j omega C4. I have substituted here. Next, Z2 equal to what? R2 is there. I will substitute R2. Z3 equal to R3 is there. We'll substitute this one here. So the rearranging this term here now, by multiplying this one, it will become R1, R4 हो गए दोनों इधर. This one. Now these two you have to split the term here. R1, R4 we have written here now. Next, this R4 you multiply here, j omega L1 into R4, j omega L1 into R4 here now, j omega L1 R4. This term, the denominator term, I will send into RHS side. RHS side गया तो ये multiplication हो जाएगा. Yes, R2 R3 into this one हो जाएगा ना. Yes or no?
Yes, sir.
1 plus j omega C4. So you substitute this R2 R3 into 1, that is called R2 R3 plus symbol j omega C4 into R2 R3. So j omega R2 R3 C4 R4 here we have written here. So what I have done here now, substituted Z1, Z2, Z3, Z4 value in the equation number 1. Next we have splitted this equation here. So this is one term we have made. This complete is one term, and by sending this denominator into this, right, RHS of the numerator, this is one term I have made here now. So by splitting the term R1 R4, j omega L1 R4 equal to R2 R3 plus j omega R2 R3 C4 R4 will get one equation, will get that one. Now separate the terms here. real term and imaginary term, to separate it. By separating the real term and imaginary term, what is the equation we'll get? Can anyone tell? Yes. Which is this is R1, R4 is the real term or imaginary parts? R1, R4.
Real.
This is real term. So I will write here. I will write here. I will write R1, R4, R1, R4. Next, this one J omega L1. This is imaginary term. I will mark imaginary term. Equal to is there. I will write equal to here. Next, this is R2, R3.
Real.
Real term is there. So this is imaginary term is there. What I will do first, I will calculate the real term. R1, R4 equal to R2, R3 here. R1, R4 equal to R2, R3. You can check this one. It is same like a Whitson bridge now. R1, R4 equal to R2, R3.
Yes, sir.
So from this one, the unknown resistance, that is R1, we have calculated here. R1 we have calculated. Next we will go for the imaginary term here now. Imaginary part of the equation here now. So J omega L1, that is into R4 equal to J omega R2. Tell the equation. R3 C4 R4 is there. Okay, C4 R4 is there. See here J is there common. Here also J is there. We can cancel J. We can cancel or not? J
Yes.
will cancel here. J will cancel here. No. Omega.
Yes.
Yes, sir.
J will also get cancelled. Next R1 L1 term is there. No L1 term. R4 term is there. Here. Yes, it is there. R4 term is also there. So R4 get cancelled. So the term left L1 equal to R2, R3, C4. So the term L1 equal to R2, R3 plus C4. That is called L1 impedance here now. So is there any capacitance formula we have identified? No. The unknown inductance only we have used by using the Maxwell inductance and capacitance bridge. In the circuit we are using the capacitance over there here now. So this is the inductance capacitance bridge here now. So we have identified two unknown equations. One is for R1, another one for self-inductance. Both are independent of each other here now. So from this one, we can calculate the quality factor also. The quality factor is important to how much quality it is there. So for that reason, what we will do, the quality factor expression is always is nothing but Q factor we are going to call. Q factor is nothing but XL divided by R1 we are going to call that. XL divided by R1. XL equal to omega L1. So equation number 1. So omega L1, omega is as it is, we will write that one. R1 already we got equation here now. From this we will calculate that one. I will write here omega L1 equal to what? Formula R2 R3 C4. है ना, यही है ना?
Yes, sir.
Next divided by R1 equation क्या है? R2 R3 divided by
R4.
divided by R4 here. Divided by R4. So here R2 R3, here R2 R3 will get cancelled here. No, here this is 1 by R4 is there. When I will send into here, it will become omega C4 as it is. Omega is there, C4 is there. Next this R4 you will send into here. R4 is there. Is it correct? This one we got the Q factor also. We can derive from this equation here. We get the formula for the quality factor also. So it completes the Maxwell bridge. The next class we'll discuss about next bridge. So advantages of Maxwell bridges are there. Here the balance equation of the circuit is free from the frequency. Whatever the balance equation we have identified, that is free from free from the frequency. Both the balance sequence are independent of each other. Whatever I told, that is one एक equation के ऊपर दूसरा dependent नहीं है, so independent of each other है. So the Maxwell inductors capacitor bridge is used for the measurement of high range inductance के लिए. So for the medium to low range, we are going to use only for the inductance bridge, but for the high range of inductance measurement, we are going to use the inductance capacitance bridge. We are going to use that one here. It has some disadvantages also. The main disadvantage of the bridges are we are using a capacitance here now. Variable capacitor is there. That cost is high, expensive. So that is the one disadvantage. Another is that is used for measurement of medium quality coils only. The quality of the coil, medium quality coil के लिए use हो रहा है. Higher quality coils, it is not that much sufficient or accurate. We are going to call that one. So some problems are there. So for that reason only I told you remember this Q factor equation. You remember this two equations R1 and IL1 equations for the Maxwell inductance capacitance bridge, and for the Maxwell inductance bridge also you can remember R1 and L1 equations. These 2 plus 2 plus 1, 5 equations you have to remember. The next class will solve some numericals on the Maxwell inductance. So I'll stop here only and we'll continue in the next class. If anyone you want to ask anything means you can ask. Okay, we'll stop here only.